Now, let's go ahead for gear force analysis. Okay, first let's talk about the force on SpurGear 2 surface. Okay, here we don't have to show the gear sets anymore. You see, this is the gear triangle. Basically, it shows all the important things. Okay, pitch circle radius, and base circle radius of gear 1 and gear 2. Okay, I can name this gear 1 driver. Okay, I can name this one driven. Okay, first of all, let's just try to figure out the rotation direction without someone giving us the rotation direction. Okay, this guy is the driver gear, all right, and this is our line of action, okay, or line of generation. We have learned all those names already. Okay, if I have a pair of teeth, all right, so this is for one gear, and this is for the mating gear. All right, so currently they are touching at the pitch point. All right, it really doesn't matter where they touch. However, the thing is, if I show the gear triangle in such a direction, that means this pair of the teeth can only go along this direction because this one's the driver, so it pushes this one moving from this direction from here to here. All right, it cannot go the other way. If it goes the other way, we either have a separation or this gear 1 is not the driver. Okay, so keep that in our mind. Let's come out to these 4 questions. Where do we analyze gear force? We analyze gear force on pitch circle. Okay, or particularly at the pitch point. Okay, and the force direction is given normal to the 2 surface, which is exactly what we talk about. This is along this line AB. So this line AB is called a line of action because of that reason. Okay, as for the direction, we need to talk about, let's see about the force, okay? Normal force, particularly tangential force, okay? We have to talk about the driver and the driven. Okay, so this gear is the driver gear. So it drives, it pushes the mating surface to go along this direction. Okay, so therefore the driver feels the resistance, so the force has to be against the motion. Okay, so force direction is against the motion. Against the motion direction, okay, just against the motion. For the driven, so the force, what I'm talking about here is if the force given by the mating gear to this driver gear, okay, so that is on the driver gear surface. Now when I talk about the driven gear surface, that means on this surface, the force is given by the driver. So force given by the driver pushes these driven gear tools moving along this direction. So the force has to be along the rotation direction of the driven gear. So that's important. So the force, okay, is along the rotation direction, along the motion direction. Okay, so on the driven gear surface, the force is along the motion direction of the driven gear. So on the driver surface, the force is against the motion of the driver gear, okay, itself. So we have to make that very clear. Now, let's talk about the force on the driver. So I'm gonna remove the driven gear surface. So we only have one surface, and replace the driven gear by a force. So we can show the free body, just like we show free body diagram of this tooth of the driver. All right, so the force has to be against, okay, so that is along this direction, all right, which is along the line of action. So this is our normal force, normal to the tooth surface, okay? And we know the force, normal force, can be split into two components. Okay, let me use the vector expression. So one is the tangential direction, t for tangential, and the other one is the radial direction. Okay, so this force is split into two components. See here? All right. So this is the radial direction. So W R. Okay, and this is W T. You see here, I didn't use the vector notation because here I show the directions already. All right, so we can write down expressions very easily. And what is this angle? This is the pressure angle. This is the pressure angle. So WT equals W, okay, by cosine of the pressure angle. Okay, and WR, which is this one, equals W by sine pressure angle. So one expression and two expressions. Okay, second expression, so we get two expressions for the forces. So this force is split into these two components. However, WT is also the torque divided by the pitch circle radius of that particular gear. So here I'm talking about gear 1, so I use gear 1. And T comes from what? From power. So suppose this is the power divided by the rotation speed. So knowing the power, we can find out T. Knowing T, we can figure out the tangential force. And knowing tangential force, okay, we can figure out W. And from W, we can figure out the radial force. So all these expressions are linked. Now, why don't I move this to these things up to here? So WT is also that relationship. So W, okay, cosine phi. Okay, cosine phi. And then we can solve this WR. Okay, I can use W. I can also use a tangent. So knowing this one, this becomes tangent. Okay, equals WT tangent the pressure angle. So that's all. So we got everything resolved. Thank you.